All right, hello everyone. We're going to be talking about section 9.1. So now we're on our last chapter, chapter 9. This is going to be about frequency distributions and measures of central tendency. So a random sample is a limited sample drawn to determine characteristics of a population. A random sample is representative of the population because they're chosen so that every element of the population is equally likely to be selected. A random sample can be difficult to obtain in real life. And that's because there's so many different just attributes about people and individuals and things that they, any sort of data that you can collect, individuals vary a lot. So it's really hard to get a random sample in real life or a really good random sample in real life. But basically, when you pick this random sample, you just want to make sure that you include all the different variabilities and then make it so they're all equally likely to occur. So first we start with frequency distribution. So once a sample is chosen and this data is collected, we need to organize the results so that conclusions can easily be reached. So one method is to group data into equal intervals, with 6 to 15 intervals being the best. So if you have like a large set of data, any interval, or you can create any amount of intervals, but really any intervals that are between 6 and 15. So if a random sample has anywhere between 6 and 15 intervals, that's considering like the best amount of intervals that you can have. You can also create grouped frequency distributions. And this is like the table that we see right here. So these can be also displayed in histograms as well as tables. But it's important to recognize that in previous section, when you put these into histograms, the y-axis on histograms used to be for probability, like when we saw in section 8.5. But now they measure frequency, so these will actually be whole numbers. It's not just going to be between 0 and 1. It can be any value really that's going to relate to your frequency, but it is essentially the same. Then we have our table here, which is our grouped frequency distribution. So we see there's different number of college credits, but we have different intervals. So we see 0 to 4, 5 to 9, 10 to 14. It goes all the way up to 34. And then we want to make tallies of how often we see them. So we can just make a mark every time we see one, and then we just add them up to find the frequency of numbers in that interval. Another form of a graph that illustrates a grouped frequency distribution is a frequency polygon. They're normally graphed over a histogram as line segments connecting the midpoints of every bar on the histogram. So they don't necessarily need to be over histograms, but you'll likely see them a lot of times graphed over histograms. And basically all that you're doing is you're just connecting the midpoint or the mid value of each one of your intervals, and then you'll connect them to just create lined segments. So you'll see it go up, down, up, down, up, down, according to whatever your histogram looks like. Okay, so let's start with our first example. So we see here that we want to group the data as indicated. Then we want to prepare a frequency distribution with a column for intervals and frequencies. We want to construct a histogram, and then we want to construct a frequency polygon. So we're going to just put the frequency polygon on top of the histogram since that's how we see it a lot of the times. So our set of values here, we have this large set of values, and we're going to use 6 intervals starting with 0 to 24. So what we do here, if we're going to start with 0 to 24, since we're starting with 0, that means 25 items or 25 numbers. Since it's 0 to 24, in total it's 25. So we're going to have increments of 25. So we have 0 to 24, then we have 25 to 49, 50 to 74, 75 to 99, 100 to 124, and then 125 to 149. And then all that we have to do is put all these values in. So let's start with our very first column here. It's going to be 0 to 24. And we want to organize all of our data. So this is part A. We're just grouping our data. So we start with our first column, and we look here at our group data. So when I say column, I mean the columns that we'll be putting in part A. So we're going to line them up underneath our little titles here with our intervals. But when we go in order in our set here, we're going to go by row. So we're just going to go down each row, and then we'll put them in our columns here. So we want to find all the numbers between 0 and 24. So looking at our set here, we're going to start with our first number, and look at that, it's 7. So 7. And we'll continue to look for numbers between 0 and 24. That's close, but no. And we can keep looking. And then we have 12. That's our next value. And then we can just keep going, and then we have 2. And then we have 13 as our last value. So we've written down all of our values now between 0 and 24. So I'm going to do the same thing for 25 through 49. So we're going to start up here, and you can see my cursor here. We'll start at the beginning, and we want to find values between 25 and 49. So we're going in 26. And then 29. And then 44. And then we can keep going, and then we get 43. And keep going, keep going. We already put 12 in our very first column, so we ignore that one. And then we have 46. And 37. And we just keep going, 38. And then 32. And that would be it for 25 to 49. Then we want to go and put in our numbers from 50 to 74. So obviously we see this is going to take a little while to go through and find every single value. So I encourage you to do this on your own, but I'm going to fill the rest in for now. Okay, so we filled in the rest of our values here. So we have all of our numbers in our columns. So we have now finished A, we grouped our data as indicated. Now for part B, we want to prepare a frequency distribution with a column for intervals and frequencies. So we have our intervals, we're going to collect our tallies, and then we have our frequencies. So you don't necessarily have to have the tallies column. If you don't want to, you can just have intervals and frequencies if you'd like. But we did see tallies in this grouped frequency distribution here, so we're going to do the same thing. All right, so in our very first column, we can count 1, 2, 3, 4. So we can say 1, 2, 3, 4, and we know that the frequency is going to be 4. Then in our second column, we're going to have, it looks like 1, 2, 3, 4, 5, 6, 7, 8. So we can make these tallies 1, 2, 3, 4, 5, 6, 7, 8, or 8. Then we can look here, we have 1, 2, 3, 4, 5 in our 50 to 74 column. And in our 75 to 99 column, it looks like we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to have 10 values in that column. Then in our 100 to 124, we have 1, 2, 3, 4. So our frequency will be 4. And then our last column here is going to be 1, 2, 3, 4, and 5. So we're going to have 5. And our last column. So now what we can do is we can add all of these values up. So when we do this, we just add up our frequencies. We get a total of 36. So in all, we have 36 frequencies. So we completed B here. We prepared our frequency distribution with a column for intervals and frequencies. Now we want to construct our histogram. So we have a graph here that's for our histogram. We see we have our frequency and we have our intervals. So we created histograms in section 8.5, so we're going to be doing the same thing now. So we see we have our, I'm going to make this bigger actually. Our first interval from 0 to 24 has 4 as its frequency. So, and now in our last section we also saw that histograms, we made the value in our x axis of our histogram, we would make that in the middle. So since these are intervals, we will go back to having it in the squares between. So we see here between 0 and 24, we see that it's going to be this interval in between. And that's because it's counting the values between 0 and 24. I don't want to cover up the tally marks. But there we go. There's our first bar there on our histogram. Now we can do our second one. So we have 25 to 49. So we see there that's going to be 8. So we can draw, oh, my hands is not very steady. We can draw our bar in this case. And then we just fill it in. All right. Now we can do the same thing for our interval between 50 and 74. So 50 and 74 had a frequency of 5. So we can draw this here. And fill that in. All right, now we want to do our frequency between 75 and 99. See, that one's going to be 10, so that one's going to be pretty tall here. So it's going to go up to here. As I said before, you draw them as best as you can, but as long as you get the point across, it's not that big of a deal. And we fill it in there. All right, and then we have our next interval, which is 100 to 124. So we see that 100 to 124 is going to be 4. So we're going to draw this bar in, fill it in. Then our final bar here, we have between 124 and 149, and that is going to be 5. Yeah. There we go. All right. So now we've filled in all of our bars on our histogram, our very colorful histogram. Oh, I totally forgot that I made those colors there. So histogram, let's fill this in. Histogram is just going to be many colors, not red, I kind of forgot. But our frequency polygon will be drawn in black. So when we draw a frequency polygon, what we do is we make points on our midpoint in our on our bars of our histogram. So what I mean by that is, like, we look at our first bar on our histogram here, it's between 0 and 24. We conveniently make this bar between 2 squares, since we are looking at it on graph or lined paper here. We see that the bar is between 2 squares, so our midpoint in this case, and it's going to be at the same frequency, it's just going to have a point. So we're going to put that point right there. See, it's like right on top of that, the top of our bar, and it's right in the middle. And we're going to do that for each one of our bars here. So for 25 to 49, we're going to do the same thing. We're just going to draw a little dot right there in the middle. And we do for our next one, and our next one. And remember, they're always at the same frequency, and they're just right in the middle. So now I have these dots. When we make our frequency polygon, we're just pretty much connecting the dots. So when we do this, let's connect our first dot with our second. So we can label these if it helps. It just helps to visualize. So let's connect our first dot to our second dot. When we do that, we're going to get something like this. Then we want to connect our second to our third. So something like that. Then we want to connect our third to our fourth. Connect this as well. Covered up that 3 there, but you got the point. And then we want to connect fourth to fifth. And then our fifth to our sixth. So we made these points now, but we don't really have ends to them. So what we're going to do with this is that we pretty much just going to take our line and we're just going to extend it that way. And since we really don't know how far our graph is going to go, as long as you really get those middle points correct, that's all that really matters. But so you could see, you could draw a line going this way, you can have this line keep extending. But either way, we don't know what any value is after this, so we can't really determine. But that is pretty much how we would graph our frequency polygon. It's basically just a connection of line segments. And that's how you do them. That's why it's really helpful that if you have a histogram first, it's really easy and straightforward to create your frequency polygon because you're just connecting the midpoints and the frequencies of each one of your bars. So they're a little funky, but hopefully it won't be too hard to grasp. All right, so moving on here, we have measures of central tendencies. So 3 mathematical quantities are used to describe the average. So these could be pretty familiar to some of you. If not, that's okay, because we're gonna go over them. So we have mean, median, and mode. So we're gonna start with mean. So the mean, or the arithmetic mean, or just mean, because we call it mean, we don't call it arithmetic mean that often, of a set of numbers is the the sum of the numbers divided by the total number of numbers. So this means that the mean of n numbers, x1, x2, x3, all the way to x7, is x, and then this is how we would write the mean or median or anything like that. If we want to find the average, we usually put a bar over our variable. So in this case, we have x, so we put a bar over, and we call that x bar. So x bar, or just the mean, is equal to, and that sign is called the summation of your values of x divided by n. So this is the theoretical definition, but basically that means that if you have the values, just do a little side note over here. If you have like a set or a list or anything like this, so let's just make it a list, not a set. So if we just had like 5, 7, 8, 4, and you want to find the mean, you just add these values up and you divide by the number of numbers. So there's 4 numbers, because see 5, 7, 8, 4. It's 4 numbers. You add the values up. This is going to be, think of, I think this is actually going to work out. This is going to end up being 12 plus 12, so 24, divided by 4, and we end up getting 6. So that'll be the mean of these values. So that's just how you would calculate it. You would have all your values, you would add them up, and then you divide by the number of values you have. All right, so example 2, we want to find the mean of the following data. So we're going to do the exact same thing that we just did. First things first, we want to calculate n, which is the number of numbers. So n, in this case, we see it's going to be 12, 17, 21, 25, 27, 36, and 49. So we have 7 values. And then we just want to add them up. So our mean is going to be equal to, and then we're going to have 12 plus 17 plus 21 plus 25 plus 27 plus 38 plus 49 Let's move part B over so we have some more room here. Let's put it right here. So we're going to add all these numbers up, and we'll divide by our number of numbers, or value of n. So I invite you to calculate this value on your own. You should end up getting 189 divided by 7, which is just equal to 27. So we say the mean of our following data, or our list of numbers here, is going to be 27. So now we can do part B. So we'll just do the exact same thing. So we want to find n first, so 21, 3, 5, 47, 19, and 30. So 6 numbers. And then we just add them up and divide by a number of numbers. So we have 21 plus 3 plus 5 plus 47 plus 19 plus 30. These are all divided by 6. So once again, I recommend that you calculate this number on your own. If you do, you should end up getting 125 divided by 6. So we usually want to calculate this number and we want to have it in decimals, just so we have a better gauge of what this number is, apart from just 125 divided by 6. So if we calculate this, we should end up getting about 20.83. So we know here that the mean of our values here is going to be 20.83. All right, so now we have a little bit more experience calculating the mean. We want to move on to example 3. So we want to find the mean for the data shown in the following frequency distribution. So we see here we have calculations for frequency distribution. We have our value, which we call x, our frequency, which we call f, and then what we're going to do is we're going to have our product x times f. So we need to introduce our product column since the values are going to be appearing multiple times. So we see 21 is going to appear 6 times, 24 is going to appear 8 times, 25 is going to appear 9 times, 25 appears 9 times, 29 appears 13 times, and 32 appears 4 times. So we need to have the product so that we actually kind of combine these ideas and that we have a value that's going to show up multiple times. And when we have this product, or when we introduce this product, what we're doing here is we're actually taking this into consideration. So our mean is actually a logical value. It's not going to be something completely off. So in the case where you have values and then the frequency of the values, you want to find this product column. So we have here, when we add up our frequencies, it's just going to be 40. But our product, when we add them up, is going to be 1,048. And you can do these calculations on your own if you'd like. I just did them ahead of time since this wasn't the important part of this problem. And so we have our total number of frequencies and our total number of products. So if we want to calculate our mean, and remember we write mean as x bar. We can either just write mean or we can write x bar. Either way that you write it, it's still just the mean. And when we have our products and our frequencies, what we do is we divide products by f, or frequency. So product, which is just x times f. So, and we want to take our total, remember, so this is our total. So there's a lot of rewriting here. So it's our total of x times f divided by our total of f. So this means we take our totals, so we have 1,048 divided by 40. So now, when we calculate this value, we should get 26.2. Now if we look here at our numbers, we have 21, 24, 25, 29, and 32. So if we think about it, 26.2, okay, well that actually does land pretty much in the middle or in between 21 and 32. So that's what you really want from the mean. You want to find the number that's going to lie somewhere in the middle or in the average. And if we hadn't have found our products and our frequencies, we could get a value that maybe isn't even in between these values, or it wouldn't make sense or something like that. So that's why we have to use our product, because we see these numbers appearing multiple times. All right, so our mean was 26.2. So we see that we calculate the mean differently with a grouped distribution like in example 3. So that's what we talked about when we introduced this product column. We calculated the mean differently with grouped distributions. So now we have our theoretical definition of the mean of group distribution from your book, and this is going to be the mean of a distribution where x represents the midpoints, f the frequencies, and n is equal to the sum of the frequencies. That's what that, the notation is called sigma, so that's the Greek letter sigma, but it's just the notation for the sum, so this means that you add up those values. And we see that our mean, or x bar, is going to be equal to the sum of x times f divided by n, which is the sum of your frequencies. So that's what we said before when we said our total products and our total frequencies. All right, so now for example 4, which is going to be your turn number 2 in your book. We want to find the mean of the following grouped frequencies. So we have our interval and we have our frequencies, but since we don't really have a value, it's just an interval, we don't really know what number is coming up multiple times since it's just an interval. We just know that some numbers in between these intervals are showing up twice. So what we're going to do for problems like this is that you want to find the midpoint. You're going to take the midpoint of your interval, and then that's what you're going to multiply by your product. And this just gives us, once again, because what we're doing here is we're just trying to find the average or the center. So we're just trying to find the value that's going to fall somewhere in the middle. And so it doesn't, it doesn't always have to be exactly with problems like this when we have intervals of numbers showing up. We just want to get close. So we have our interval from 0 to 6. Since it's from 0 to 6, that's 7 values. So if we want to find the midpoint between 0 and 6, what do we think it will be? We have 0, 1, 2, and then 4, 5, 6, so 3 is going to be the midpoint. And you could also just find this by adding the two values and dividing by 2. So we know this is 3, I'll put it over here actually. We know this is 3, but we can also find that this is 3 because we're going to take 6 plus 0, or you can do 0 plus 6, doesn't really matter whichever way you do, divided by 2. And then our second midpoint for 7 to 13, that's going to be 10. And that's because when we do 7 plus 13 divided by 2, that's going to be 20 divided by 2. So this is how you would find the midpoint, or sometimes you can just look at it and pretty much figure out what the midpoint is going to be by looking, but if you don't, this is a really easy way. You just add the two ends of your interval and you divide by 2. So I'm just going to fill in the rest of them. So we see 3, 10. The next one will be 7, and then 24, 31, and 38. So also, if you notice, our midpoint is going to be increasing by 7, and that's also because each one of our intervals is spaced out by 7. So our midpoints are also going to be evenly spaced out. All right, so now we have our frequencies. So we know our midpoint and we know our frequency. So what we're going to do now is we're going to multiply our midpoint by our frequency, and that's going to give us our product. So our product in this case is just going to be 2 times 3, which we know is 6. For our second value, this is going to be 4 times 10, which we know is going to be 40. Then our next one is going to be 7 times 7, which is 49. Then we have 10 times 24, which is 240. And we have 3 times 31, it's going to be 93. And 1 times 38, and that's just going to be 38. So now we have our midpoints and we have our products. So we know now that our total, and remember we're thinking about our total number of frequencies. So our total number of frequencies, we add all these values up, and this is going to give us 27. Then we want to find our total number in our products, and if we do that, it's going to be 536. And then we know our mean, or x bar, is equal to our total products divided by our total frequencies. So that's going to be 536 divided by 27. Or if you calculate this value on your own, you should end up getting 19.85. And that is what we're going to call our mean in this case. And if we see we have intervals between 0 and 41, and so we see 19.85. If you actually just take 0 and 41 and you divide it by 2, you know that it's going to be just a little bit over 20. This is really close to 20, so we could say, okay, this is going to be our mean. And we know that our mean is going to change based on the frequencies of our intervals here. So our mean is going to be influenced by the frequencies of our intervals. All right, we got that our mean would be 19.85. All right, so in section 8.5, we figured out how to calculate the expected value of a random variable when we know it's a probability distribution. So remember, we did our expected values. In those cases, we had our x sub 1s times our probability of x sub 1s, and then all the way until x sub 9, and that gave us an idea of the average. So the expected value is sometimes called the population mean, denoted as the Greek letter mu. So sometimes you'll see it be written as E of x is equal to mu. But this is basically just to say that the expected value and the mean are essentially the same thing in a lot of situations. So expected value, sometimes called population mean. So especially when you're working with populations, the expected value is the mean. All right. Now we can talk about the median. So the median is the middle entry in a set of data arranged in increasing or decreasing order. So when we're working with our mean, that was a lot more of calculating what like that middle point is going to be. And it doesn't matter what our actual numbers were, it's just what that middle point would be. But with our median, what we're doing here is we're picking the middle entry in a set of data. So if you have 7 numbers, then your fourth number is going to be what your average is when it's arranged in increasing or decreasing order. So whatever you have, whatever set of values you have, whatever number that is just the literal middle value in your list, that's the median. Not the calculated middle, just literally the one in the middle. So, okay, so we're gonna put this into practice. So example 5 here. We want to find the median of each listed number. So we see here, they're already in increasing or decreasing order, so we don't have to rearrange them. But we see here we have 9, 10, 13, 17, 20, 22, and 25. So we see here that's going to be 9, 10, 13, 17, 20, 22, 25. So it's 7 numbers. So 7 numbers, we see there's 3 numbers here, 3 numbers here. So this is our middle number. It's the middle. It's the number that is smack dab in the middle. There's 3 on each side. So it's right in the middle. It's in increasing order. So we say that the median is 17. So we say median is 17. Like we said, it's the number that is just smack dab in the middle of this list. All right, so now for part B. We have 33, 39, 42, 47, 54, and 56. So in this case, we have 6 numbers. So no number is going to be smack dab in the middle, because we see here if we do 3 and 3, it's 3 and 3. Well, there's no number right in between our highlighted portions. So what we're going to do is we're going to take our middle numbers, so in this case 42 and 47, and now is when we're going to try and do that midpoint idea again. So we're going to take the midpoint of these two numbers. So when we do this, we'll say our median is equal to 42 plus 47 divided by 2. So when we add these values together, this is going to give us 89 divided by 2, which is the same, or which is equal to 44.5. So in this case, this number isn't actually in our list because we had a set of even numbers. But if we're thinking about our actual list, 44.5 would technically be right in the middle. So that would be our median in this case. All right, then for our last part C here, we have 113, 96, 91, 87, 82, and 75. So we have decreasing order this time. And once again, we have six numbers. So you see here we have 3 and 3. So we're going to do the same thing. We're going to take our middle two values. And we know our median. We're going to add them up, divide them by 2. It's going to be 91 plus 87. Divided by 2. This is going to give us 178 divided by 2, which is going to be 89. So we see 89 is not actually in this lineup of numbers here, but 89 would be right in between 91 and 87. All right, so we did problems with our median. Now we're going to go on to our last example here, which is mode. So mode is the number that has the most frequent entry. So that means that if you have a long list of numbers and one number shows up more than any other number, that would be your mode because it's the most frequent number that you're seeing. So for example 6 here, we want to find the mode for each list of numbers. So we see here we have longer lists of numbers, but we don't have to count them. We just have to see which one is going to appear the most. So if we're looking here, we see 21, 33, 8, 22, 33, 41, 56, 81, 33, 56, 22, and 37. So if you take a look at our list, maybe count up how often each one of them appears, maybe one stands out, and we see that 33 appears 3 times, which is the most entries. So we get that the mode is 33. Now we can do problem B. So we see here we have 234, 49, 171, 49, 53, 211, 171, and 57. So we see here, well, 177 shows up twice, 49 also shows up twice, and everything else shows up once. So 2 things show up twice, that just means that we have 2 modes. So we see 49 and 171 both appear 2 times. And this is the most entries. So we say the mode is 49, and we usually just put a comma, so 49 and 171. So we can have multiple modes. If we see that multiple numbers show up the same amount of times, we can have multiple modes. It doesn't have to be just one or another or anything like that. You can have multiple. Then for part C, we have 7, 81, 76, 52, 64, 43, 39, 22, and 14. So when we look at this list, we see that each one of these numbers only shows up once. We say each number only appears once. So since each number appears just once, the thought process is, okay, well, either each one of these numbers is the mode, or we have no mode. Well, each number is only showing up once, so we wouldn't really say that the mode would be all of them, because that would be a really, really long list of numbers, and then just why would you have that? So if each number only shows up once, or if every number shows up twice, so basically if each number shows up the exact same amount of times, then we say there's no mode. So in cases like this, we say there is no mode in this equation. There's no average, or there's no center. All right. So the mean, median, and mode are examples of a statistic. So this is really the first technically example we see of a statistic, which is simply a number that gives information about a sample. They all measure the center or the average of data. So there was a common theme there. They both measure the average or the center. So some downsides of each one of these things are, or each one of these central tendencies, because they're all great in different circumstances, but they each do have downsides. So the mean tends to be influenced by extreme values. So say you have a lot of numbers that land around 70, but you have values of 0 and you have values of 120. Well, when you calculate your mean, that 0 and the 120, those are going to influence your mean a lot. So your average might actually not end up to be about 70, even though a lot of the values are around 70. Then we have that the median can make for really long lists of values. So let's say you have a really, really large set of data, and you want to find the median, but you don't want to arrange all of those values unless maybe you have like a code that would do it, or some sort of system that could do it for you. Then that would be pretty nice. But if you're doing these by hand, which you will be in our class, they can make for really long lists of values, and that's just really unrealistic to think about. So that would be a downside of a median. But then we have lastly our modes. They may not even be in a sample, or you can have multiple. So your mode, there may not even be any, or you can have multiple. And that can be helpful at times, but if you're just trying to find the average and you find that there's no mode, well, there has to be an average. It's just that there's not any numbers that appear more than the other values. So those are just some downsides. So usually in questions it will ask you, calculate the mean, calculate the median, calculate the mode, or something like that. But if it ever came down to decide which one to use, these would be definitely some downsides that you would have to think about when figuring out which one you should use. All right, then for our last example here, we have example 7. So the number of nations participating in the Winter Olympic Games from 1968 to 2014 is given below. Find the following measures for the data. So we have our set of data here, we have our different years, we have our nations participating, and we want to find the mean, median, and mode. Let's start with the mean. So if we want to start with the mean, we know our numerator is going to be the sum of all the nations participating for every year. So if we want to do this, then we're going to take 37 plus 35 plus 37 again, plus 37 plus 49 plus 57 plus 64. This can get pretty tiring as well. Plus 67 plus 72 plus 77 plus 85 plus 82 plus 89. So this is a problem that you really want to have a calculator on. And then we need to divide by the total number of years. So if we added up each one of these years, we're going to get some incredibly large number in our denominator. So we don't want to add up the actual value of years. Remember, we're adding up the number of years. So we see 1968, 1972, this would be like year 1, year 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to be 13 years in total. So we divide each of these, the sum of all of our values, by 13. So now you want to add up all of these values. And once you do, you should end up getting 788, we're going to write x bar, 788 divided by 13. And this is going to be 60.62. So we see our mean is going to be 60.62. Now once again, obviously we see you can't have 60.62 teams, but this is going along with that idea that if we did this for a really long period of time, multiple times, we see the average or the mean would be 60.62. If you wanted to round up, you could say or 61 teams if you wanted to round up. All right, so now for part B, we want to find our median. So if we want to find our median, remember we need to arrange them in increasing or decreasing order and then pick the value in the middle. So there's 13 numbers here. We're gonna arrange them anyway. It's 13 values, but we do it. So we want to find our smallest value, and it looks like our smallest value is going to be 35. Then our next largest value, it looks like we're going to have 37, and it looks like it's going to appear 3 times. So we're going to have 37, 37, 37. Then our next highest value is going to be 49. And our next value is going to be 57, then 64. So we see here that as the years increase, we actually do kind of have a natural increase in our values, but we will see that it's not always the case. But we do see that it is increasing so far. We have 67, 72, 77, but then we see we have 85 in 2006, and then we have 82 in 2010. So 82 will be our next value. 82, 85, and then 89. And we know there's 13 values, so that means that our middle value should have 6 values on each side. So we can say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So our middle value in this case is going to be 64. So we say our median is 64. All right, now for our last part, mode. Thankfully, we already kind of wrote all our numbers in order and in increasing order, so it's going to be very obvious which is going to be our mode. Which if we look here, every number pretty much shows up once except for 37, which shows up 3 times. So we say for our mode, we already arranged them in part B, and we see 37 appears 3 times, which is the most entries. So we see our mode is 37, so that's going to be our most frequent value. All right, and that's how you would calculate your mean, median, and mode in kind of more real-life examples like this. Okay, so that pretty much concludes section 9.1, all about our frequency distributions and measures of central tendencies. Hopefully part of it should have been somewhat familiar once we answer mean, median, and mode, but if not, that's okay because we went over it anyway. So as always, if you have any questions or concerns or anything, feel free to email me, submit an anonymous question to our anonymous question form, or you can pop in my office hours at any time. All right, I'll see you all virtually later.